Hello everyone. In this video, I would like to go over the basic concept of simplified algebraic expression and then solve for x as a linear equation. So for this particular question right here, it's asked us to simplify. So for us to simplify an algebraic expression, we need to combine the like terms. So before we can combine like terms, we need to apply the distributive rule so that we can open up the bracket. So distributive rule saying that you should take whatever coefficient outside this bracket here, and then you multiply with each term inside the bracket. So while multiplying, be mindful of the negative in front of this coefficient. So if I have negative 17 multiplied by 5a, the answer should be negative 85a. Continue with that, I take negative 17, I multiply positive 3b, so the answer should be negative 51b. Continue with this, is a negative 4, so I take a negative 4, I multiply inside the bracket with the term 7a, so I should have negative 20a. Okay, so be very careful right here. The negative multiplied with a negative 12 will give me a positive answer. So it will be a positive 40ab. So at this point, once we have already distributed the term, and now in this expression, what you can do is you can try to find the like terms in order to simplify. Like terms means that you should have the variable as the same. So in this case, I should have this and this I can combine, right? So applying the operation for this one, I should have a, I keep it as the same coefficient, but I will have to combine the negative 85 with the negative 28. So in this case, I should end up with negative 113. So this process involving the coefficient in front of the variable is called operation of integers. Alright, so negative 85, subtract 28, you should have negative 113, and you keep the same variables. So the next step is we need to combine this term and this term. Alright, so combining this, because we are having the like term as b. Okay, combining the up term as b. So then I will write the b. Then the operation of the integer for the coefficient would be negative 51 plus 48. So negative 51 plus 48 will give me negative 3. So in this case, the final answer would be negative 113a subtract 3b. At this point, we cannot go any further. We already simplified. We cannot combine these two terms because we don't have the like term. So this is the variable a and this is the variable b. So that will be the final answer for this questions. Alright, so let's move on to solving for x as a linear equation. When we're talking about linear equation, that means the exponent for x is equal to 1. Okay, in every single linear equation, the exponent for x will be 1. The exponent will tell me how many solutions that I have for x, for this equation. So the solution for this is only one solution for x. So in solving for x in the linear equation, what we need to do is we need to apply the opposite operation so that we can isolate the unknown. So what do I mean by the opposite operation? So in order for you to isolate the x, that means you must have one x. Alright, so the first term to remember is isolate x. So what does it mean by isolate x? Isolate x, that means you just have x on one side of the equation. The rest of it you have to bring it over to the other side. So how do we get rid of negative 3 in front of x? So multiply by negative 3, we need to divide it by negative 3. So I should have negative 3x divided by negative 3, that will give me 1x, right? However, because it is an equation, whatever I perform on this side of the equation, I must do the same thing on the other side. So then I should divide it the other side by negative 3 as well. So from here, you see that negative 3 divided by negative 3 will give me just 1x left. And then on this side of the equation, I have negative 3 divided into 15, so the answer should be negative 5. All right. Okay. So we can check, right? So you can always check to see if you've done it correctly. So this is very simple to check. We can even do this in our head. But the simple questions here is to apply the concept of you have to perform, like somehow get rid of the negative 3 in front of x. So multiply by negative 3, then we must divide it by negative 3 to get x into just 1x. Right? So negative 3 divided by 3 is 1. And we don't have to write 1x, we just have to write x. Okay, so it's understanding that x by itself will be 1 times x. So in this case, you already isolate x. So for us to check, then we must do like the left-hand side equal to the right-hand side. So the left-hand side, I got negative 3. I substitute 5 in here. So I suppose to have 15, right? So negative 3 times negative 5 will give me positive 15. So 15 equal to 15. Left-hand side equal to right-hand side. Then I have the correct solution for x. Okay. So again, I will apply all of this concept throughout the entire lesson. So I will have x divided by negative 4 equal to 8. So what I will do is I will have to perform the operation so that I can get just x isolated on one side of the equation. So in this case, I divided by negative 4. In order to get rid of negative 4, I must multiply by negative 4 because division is the opposite operation of multiplication. Okay, so x divided by negative 4. I will multiply this side by negative 4. Okay. And then I must do the same thing on the other side of the equation. So once I perform this step, it means that I can get rid of this. So on this side of the equation, I just have x left. So x is equal to a negative 32. All right. You can always check. You can always check your solution. So if we check this, you must have left-hand side equal to the right-hand side. Okay, so then we have x, which is negative 32 that we found, divided by negative 4. Okay, see if this is equal to 8. Negative 32 divided by negative 4 should give me positive 8, so 8 equal to 8. So we already know that the right-hand side equal to 8, but we need to show that we perform the operation on the left-hand side of the equation to show that its two numbers equal to each other. Therefore, we have a correct solution. All right, okay. So for this question number 4, it requires us a few more steps. Okay, so we, according to this, okay, so in order to solve for x, and then isolate the x, you have to apply the concept of opposite operation, also the reverse of that mass. Okay, so what you need to do is, if you have negative 2x, subtract 5, the operation that you need to get rid first is the negative 5. So you have to bring the negative 5 somewhere else or get rid of it before you can get rid of the negative 2. Okay, so bad math telling you that you have to do brackets, right? So let's go over that bad math. Okay, so brackets, exponent, division, multiplication, addition, and subtraction. If you have an expression, then you must perform this order operation. But when you are solving for x, okay, so if you are solving for x, what you need to do is you cannot get rid of the negative 2, but you have to get rid of the subtract the 5 first. So that's what I call by the reverse operation of BADMAS. Okay, or they use the word SAMDAP. Okay, SAMDAP, reverse operation, and also the opposite operation. Okay, so we need to apply that two concepts at the same time. So you will see that on above here we have the operation is -3 times x, and you have nothing else involving the operation of x. So in this case, you have to get rid of the -3 first, right? So you have, it's not first, that's the only one choice that you have anyway. So you divide it by -3 to get rid of it. Here you multiply by -4 to get rid of it. But in this particular equation, what you have on this side of the equation involving the x is you multiply -2 with x and you subtract 5. So what you need to get rid first is the subtract 5. Okay, get rid of subtract 5 first before you get rid of the -2. That means you apply this concept right here, the reverse operation, okay, and then apply the opposite operation at the same time. The reverse order of operation and the opposite operation at the same time. So what do I mean by that? The opposite operation at the same time means that since I need to get rid of the subtract 5, I have to add 5. Okay, that means I add 5 on the other side as well, because it is an equation. Whatever you do on this side, you must do the exact same thing on the other side. So then you see -5 plus 5 is gone. So what you have left in this case is -2x equal to 26. So you simplify your equation up to these operations. That means now -2 times x. So at this point, what you do is you will divide both sides by -2 to isolate the x. So that is the concept of the reverse BADMAS and the opposite operation. Okay, so I divide both sides by -2. So I should have that cancel that. I should have x equal to -13. All right. Okay. So what I'm going to do is I am going to check. Okay. So I want to show everyone how to check here. If you want to check your equation, you always write left-hand side equal to right-hand side. Because what you need to do is you need to see what happened on the right-hand side. So right-hand side is always equal to 21, right? But on the left-hand side, what you have is you have this operation. Now you are going to substitute the value of x in here, which is equal to -13. Okay? And then, according to this expression, you must perform BADMAS, right? So here's your BADMAS. Once you have the actual value of x. But when you solve for x, you must apply SAMDAP. Okay, so in this case, what you have is -2 times -13 will give me -26, or +26 is +26. Okay, negative times negative give me a +26. Excuse me. Then subtract the 5. This is 21. You see, 26 subtract 5 will give me +21. So 21 equal to 21. I have the correct solution. All right. Okay. So BADMAS applies to an expression when you just have number, when you don't have to solve. Okay. SAMDAP is the concept that you must use when you want to isolate x. So what I meant is when you isolate the x, you have to get rid of what is surrounding the x. On this side of the equation, surrounding the x, you have -2 times x and subtract 5. The operation that you must perform first in order to get rid of the subtract 5 is +5. And then later, you get rid of the multiplication of x, which is multiplied by -2. So let's continue with the next questions. Okay. So in this case, you have x on both sides of the equation. Okay, so it's just still the same concept apply, even though you have x on both sides of the equation. So what you have here is what I'm going to do is I will, at the same time, okay, what you see is you want x to be on the right hand side or the left hand side. It's entirely up to you. Okay, it doesn't matter where the x is either, given the fact that it must be isolated. Okay, x is isolated, and then it can be presented on the left hand side or the right hand side. So I can clarify that by saying this. Okay, so for example, x equal to negative 13. Okay, I can write it negative 13 equal to x, and it's the exact same thing. Okay, so you see, solving for x doesn't have to be on the right hand side. X can be on the left hand side and presented like this as well. So these two statements are the same. So for this particular one, you can just leave x on this side of the equation, or you want to leave x on the right hand side of the equation. It's entirely up to you. However, what I will do is I will leave x on the right hand side of the equation. So for that, now you know that you need to get rid of the negative 25x because you don't want x on this side of the equation, right? Okay, so let's write the equation again like this, exactly how it's supposed to be. So you have negative 15x equal to 25x subtract 80. And what I have in this case is I have 25x, and I don't want x on this side. So I need to get rid of the 25x. So I'm going to subtract the 25x here. That means I must do the same thing on this side of the equations, right? Yeah. So then 25x subtract 25x is gone. So on the other side, I combine these two coefficients. I should have negative 40x. And on the other side, I have negative 80 left. So now you bring your equation to the simplified version. And what you do next is you will divide it both sides by negative 40. Okay. So we must divide it by negative 40 in order to have just x on this side of the equation. So x should be equal to positive 2. Okay. So now we can check, right? We can check our solution to see what happened. So we will say the right hand side equal to the left hand side. So I'm going to write that I'm going to check the solution. Okay, right hand side, is it equal to the left hand side? Okay, so then right here you have negative 15. X is, you found it as 2. So you write here as 2. Is it equal to 25 times the x? So we must check on both sides, right? So then we should write that 25. And then we multiply by 2 to see if we have both sides equal to each other. So negative 15 times 2, I should have negative 30. So on this side, what I get is this time this will give me 50, subtract 80. So this side should be equal to negative 30. So you see now both sides is equal. So the concept to perform the check is you must do the operation on both sides. And then at the end, you compare to see this number is equal to this number. Then that means left hand side equal to the right hand side. Alright, okay. So whatever operation, bring it down here. Whatever operation bring it down, in the end, it should conclude that both sides are equal to each other. Okay. Okay, so let's move on to the next question. Alright, so this question is a bit lengthy. Okay, but what we should do is we take a look at what we have on the right hand side and on the left hand side. So the first thing you want to do is you see if you have any like term that you can combine. Okay, so on this side of the equation, I should be able to combine this and this, right? Because they are just operation of integer. And on this side of the equation, I should be able to combine this too, because I am able to combine the like terms. Okay, so negative 52 plus 26 will give me negative 26. So negative 26, but I still have to write subtract negative 38x. And for this one, I should have plus 49. But if I combine the coefficient, negative 39 plus 26, I should have negative 13x. Okay. So now what you see is you want to have x on this side of the equation, and you don't want the negative 13x on this side. Okay. At the same time, what you want to do is you want to get rid of the negative 26 as well. Okay, so I will do two operations at once on the next line. So I will rewrite negative 38x because I want the 38 to stay on the right hand side of the equation. And I have negative 26. So what I will do is I will so I'm going to give myself some space, and then I will perform this for you to see. Okay, so here, exact same thing on the top, right? Negative 38x subtract 26, negative 13x plus 49. I just rewrite exactly what I have. Then I want to get rid of the negative 26. That means I'm going to add the 26. I do the same thing on this side. But on this side, I want to add the negative add the 13x so that I can get rid of this x. So that means on this side of the equation, I have to add the 13x as well. Okay, you see that this number and the operation should be the same on both sides. And this number, the operation should be the same on both sides. So the purpose of that is what? So this and this is gone. Okay, and then what you can do, and this is gone. So now what you have is you can combine negative 38x with positive 13x. So combining these two, I should have negative 25x. And combining these two, I should have 75. Okay, so now I can take negative 25, divide into both sides of the equation. So this gone. This should give me just x left. And then the answer for this one is 75 divided by negative 25. It should give me negative 3. Okay, now we are going to do the check. Okay, so make sure that we know how to check our answer. The right hand side equal to the left hand side. So that means you are going to rewrite the exact equation that you have. Okay, so you will write negative 52 negative 38x plus 26. So that the exact same thing on both sides. Negative 39x plus 49 plus 26x. Exact same thing on both sides. And what I'm going to do is I will replace the negative 2, the negative 3 into this. Okay, so that's how we have to check. So I will write this as negative 3, and then I will write it as plus 49 and plus 26, and then I will do negative 3. Okay, so let's see what we get. Alright, so this one will give me 38 times 3. So negative 52. This should be a positive 114 plus 26. Okay, 39 times 3. This should be a positive 117 and plus 49. And 26 times 3 should give me 78. It should be a negative 78. Okay, so let's see what we have. You can just use your calculator and then check your answer. So on this side, I should have 88. So let's see if we have the same thing on the other side. Yes, I have 88 as well. So left hand side equal to the right hand side, then I should conclude that both sides is actually the same. All right, okay, so let me put it here, left hand side equal to the right hand side, just to make sure that I have done all that. I also should rewrite this as well. Left hand side equal to the right hand side. I should not reverse the order. So left hand side equal to the right hand side. So basically, let me conclude this. What I have here is the operations on this side of the equation and the operation on this side of the equation. And because you isolate the x, okay, so you take a closer look at all the operation here. What can you combine? Okay, so you can combine the integer. Here you can combine the like term. So after you come up with this, you are going to think that I'm going to isolate the x. Therefore, the 38x, I leave it the same, but the negative 26, I must add 26. Okay, do that on both sides of the equation, because that's what you need to do. Perform one operation on this side of the equation, you must do the exact same thing on the other side. And on this side of the equation, you have negative 13x, and you don't want the x here, because you want x on the left hand side. So in this case, what you do is you are going to get rid of the negative 13x by adding 13x. Doing that, you must do the exact same thing on both sides, right? So doing that, you achieve your purpose that negative 26, positive 26 is gone. And you have all the x term on this side, combine the two coefficients, you have negative 25x left on this side of the equation. For this, you get rid of the x as you want. You don't want x on the right hand side, and you combine these two numbers. You bring x to the simplified version, and then you get rid of the negative 25 by divided by both sides by negative 25. All right, so what I'm going to do is I have 2 more questions here, and I will do this on the next video, because each video is 30 minutes. And don't forget to do the check. If you perform the check, you should realize that the left hand side equal to the right hand side. Then what you need to do is you rewrite exactly what given to you as an equation, okay, and then you substitute the value of x into here in order to perform all the operation to see if the left hand side equal to the right hand side. So don't skip any of this step, okay? Don't start checking your solution from here. Don't start checking your solution from here, because if you make an error in here, the solution for x will be an error, and that means you take an error and check the error. It's not that you are checking whether or not you have the correct solution. All right, thank you everyone, and the 2 questions will be on the next video. All right, okay, thank you.